Hey everybody, and welcome back to Unit 6 Problem Solving, Part 2. In this video we're going to show some more examples of problem solving. And as always, when we problem solve, we want to use our problem solving process. So step 1, draw a picture. Step 2, write the given. Step 3, write the unknown. Step 4, pick an equation to solve for the unknown. Step 5, rearrange if necessary. Step 6, check your units. And step 7, solve the equation for the unknown. So we talked last class about how we choose our equations, whether or not we need those component equations. But when we talk about that unbalanced force, the unbalanced force is just the difference between opposing forces. So usually in a problem, we want to first find what the unbalanced force is, and from there, we're able to then find the acceleration. Usually we're not given enough information right out of the bat to be able to find the unbalanced force using Newton's second law, Fu equals ma. So we want to find the unbalanced force by taking that difference and then using that Fu equals ma equation to find our acceleration. So in the last video you saw examples of acceleration to the right or to the left in the x direction, and in this video you're going to see examples of acceleration up and down in the y direction. So our first example is a falling object. So a 2.5 kilogram rock is dropped from a 14-meter tall bridge into a river. While the rock is in the air, what is the rock's acceleration? So this is a fairly simple problem, but we're still going to set it up the same way that we would. Starting with our picture, which is the free body diagram. So I'm going to draw a box for my rock. That box represents my rock. It is in the air. It's on Earth, so we're going to have the force of gravity pulling down. But since the rock is actually in the air, that's the only force that's acting on it. If it's in the air, it can't be acted on by like any surface. It's not sitting on the ground, it's just falling through the air. So the only force that's acting on it is the force of gravity. So that's our free body diagram. So step 2, we're going to write out our givens. The first thing that we're given is the mass of this rock. It says 2.5 kilograms is the mass of our rock. So 2.5 kg is equal to m, the mass. We're also given another number in here that the bridge is 14 meters tall. So I might as well write that down. I don't know if I'll need it. I actually won't need it, but we'll write it down. 14 meters is the height of the bridge. So we'll write that down as one of our givens. Those two are the only numbers that were given in the problem, so that's pretty much all we need to write down. So we can move on to our next step, which is step 3. Step 3, what is our unknown? What are we looking for? We're looking for the acceleration, and asks us that. What is the rock's acceleration? In order to find the acceleration, though, we're going to have to know what our unbalanced force is. So that's kind of one of our other unknowns. Remember what I just said when we talked about our step process, is that first we find the unbalanced force to then find the acceleration. So step 4, thinking about equations. Here are all of the equations that we've seen in both Unit 5 and now Unit 6. Remember, our primary equation for this unit is Fu equals ma, but since we're dealing with Fg in this problem, we're not given what the weight of our rock is. We're going to have to know what Fg is. And it turns out that our Fg is in fact our unbalanced force. So that's going to be kind of our primary relationship that we're dealing with here. So first we're going to find what the Fg is, because the Fg will tell us what the Fu is, and then once we know what the unbalanced force is, we'll be able to calculate the acceleration. Okay, again, our force of gravity and our unbalanced force are related in that they're equal. They're equal because there's no other opposing force to gravity. Gravity is the unbalanced force. So for rearranging, we want to find the acceleration, so that equation we will have to rearrange, and we've done this before. To get the acceleration by itself, we want to divide both sides by the mass. So that leaves me with the equation acceleration is equal to the unbalanced force divided by the mass. Moving on to step 6, checking our units here, making sure that our units work for that rearranged equation that I just just rearranged. The acceleration, what are our units for acceleration? Well, it should be equal to the units for unbalanced force, which is newtons, divided by the units for mass, which is kilograms. Remember that 1 Newton is equal to kilogram meter per second squared. That's a Newton. So then if we divide that by kilograms, kilograms cancels out, and we are left with meters per second squared as our unit for acceleration, and that is our unit for acceleration. We've seen that so many times now, so that works out. So finally, we can move on to step 7. Again, our first kind of thing that we have to do is find the FG. What is our FG? What's the weight of my rock? So FG is equal to the mass times G, mass times gravity. So 2.5 kilograms, and remember that little g is the acceleration due to gravity, which is 9.81 meters per second squared. So if I take in my calculator 2.5 kilograms times 9.81 meters per second squared, I find that Fg is equal to 24.5 newtons, and that is down. Fg points down always. So again, remember our unbalanced force is equal to the force of gravity because it's the only force that's acting on this rock. So my unbalanced force is 24.5 newtons down as well. So then I'm going to take my rearranged equation to find my acceleration. That's the last little part of my problem. So the acceleration is going to be equal to my unbalanced force, which is 24.5 newtons, and then we're dividing it by the mass, which is 2.5 kilograms. And you might already kind of see what's happening here. Didn't we kind of backtrack? Because you'll see if you plug that into your calculator, you'll get 9.81 meters per second squared as your acceleration. And that acceleration is in the same direction as our unbalanced force, so that acceleration is down. But we already saw that number before in this problem, right? We used that 9.81 meters per second squared as our acceleration due to gravity. That's what g is. And it's a good thing that we got it as our acceleration because this is the acceleration that all falling objects have. Every object that falls is going to accelerate with our 9.81 meters per second squared. And again, the key to this problem was just finding that unbalanced force first and then using it to find the acceleration. Let's take a look at another example. Now our second example is jumping up. So Miss Nielsen, with a mass of 57 kilograms, jumps into the air by pushing on the ground with a force of 600 newtons. What is her acceleration as she jumps up? So we've talked about this conceptually in class, and now we're going to solve this problem. So first step is to draw our free body diagram. I'm going to draw a box to represent me, Miss Nielsen. I live on Earth, so obviously the force of gravity is going to be pulling down on me. So pulling straight down is Fg. And if I am pushing on the ground, I'm standing on the ground, and if I want to jump up, it just so happens if I want to accelerate up that my unbalanced force has to be up as well, right? So I'm standing on the ground, I'm pushing on the ground here, and if we remember Newton's third law, the force of me pushing on the ground is equal to the force of the ground pushing on me, right? Every action has an equal opposite paired action. Okay, so if those two forces are equal, then me pushing on the ground is equal to the ground pushing on me, so there is going to be that normal force. Again, I'm standing on the ground, so we know there's going to be a normal force. It just so happens that that normal force is a little bit bigger than the force of gravity, and we'll see that numerically later on. Moving on to step 2, writing out the givens. We're only given a couple numbers again in this problem. First thing that we see is that I have a mass of 57 kilograms. So 57 kilograms is equal to m for the mass. And then the second number that we see here is that I am pushing on the ground with a force of 600 newtons. Okay? But again, since we know that how hard I'm pushing on the ground is equal to how hard the ground is pushing on me, there's that equality, that's what my normal force is. So the ground is pushing on me with 600 newtons upward. I am pushing down on the ground with 600 newtons, and the ground is pushing up on me with 600 newtons. So that's my normal force. We also know from the last problem that we saw that our little g, our acceleration due to gravity, is equal to 9.81 meters per second squared. So we're going to write that down because we will probably need it. Step 3, identifying the unknown. Again, we're looking for the acceleration here. So what is the acceleration? Because that's what it asks in the problem. But once again, we're going to first solve for the unbalanced force before we solve for the acceleration. I mentioned earlier that if I am jumping up, that means my acceleration has to be up, and that also means that my unbalanced force has to be up as well, right? If I'm going to jump up, that means that whatever force is up has to be winning the tug of war, okay? So my normal force is actually bigger than my force of gravity, okay? I am pushing on the ground harder than gravity's pulling on me. So that means the ground is pushing up on me harder than gravity's pulling down on me, okay? So our unbalanced force is just that difference between opposing forces. So the winner minus the loser there. So Fn is winning over Fg. So Fn minus Fg is equal to my unbalanced force. That's the primary equation I will use. And then, again, we're going to use Newton's second law. Fu is equal to ma to find that acceleration. Once we have our unbalanced force from that difference between our normal force and force of gravity, then we'll plug it into that second equation. Step 5, we're going to have to rearrange again, the same that we did the last problem, so we're hopefully getting used to this. If we're trying to solve for acceleration, we want to move mass over to the other side by dividing. That means we're left with acceleration is equal to the unbalanced force divided by the mass. Step 6, we might as well check our units again, even though we just did it in the last problem. Okay, it's going to be the same thing that we saw before. So our acceleration, the units are going to be the units for unbalanced force, which is a newton, which is kilograms meter per second squared, divided by the unit for mass, which is kilograms. So we see that those kilograms cancel out, and we are left with meters per second squared again, which is what we want for acceleration. So now step 7. So if I'm going to try to use my unbalanced force is equal to Fn minus Fg equation, I need to first know what is Fg. I haven't found that yet, so that's what I should find first. So Fg is equal to mg, so we're going to plug in the mass. My mass is 57 kilograms. So we're going to take that mass and multiply it by the acceleration due to gravity, which is 9.81 meters per second squared. Again, I want to find my force of gravity so that I can discover what my unbalanced force is. So if I take 57 kilograms multiplied by 9.81 meters per second squared, I find that my Fg is 560 newtons, and again, Fg always points down. So now I can find what my unbalanced force is by taking the difference between the normal and my Fg. So I'm going to take 600 newtons and subtract my 560 newtons. Because again, that difference, the difference between my opposing forces, is my unbalanced force. So my unbalanced force is just a small 40 newtons. And it's going to point in the direction of the winning force, which is up. Right, our normal force is bigger, so my unbalanced force is going to point up. So now my acceleration is going to be my unbalanced force, which is 40 newtons divided by the mass, 57 kilograms. I'm using my rearranged equation from step 5. If I plug that into my calculator, I find that the acceleration is equal to 0.70 meters per second squared. And that's in the same direction as the unbalanced force, which is up. Again, I'm jumping upwards, so my acceleration is going to be upwards as I'm leaving the ground. So that is my acceleration. That's my answer. Again, we solved this one the same way, where we first found the unbalanced force to then find our acceleration. Okay, and the key here was just understanding that difference between our two forces that we saw in the last video as well. We also really needed Newton's third law for this problem as well. Okay, so we're going to look at one more equation, or one more example here, a descending elevator. So Mr. Willauer's cat is sitting in an elevator that starts to accelerate downwards at a rate of 1.5 meters per second. Oh, there should be a squared there. If the cat has a mass of 6.8 kilograms, what is the force that the floor is pushing up on the cat? So, as always, we're going to start with our picture, which is our free body diagram. Okay, so Mr. Willauer's cat, that's what I'm representing with the box here. Mr. Willauer's cat lives on Earth, so we're going to have FG pulling down. And it is sitting in an elevator, and that elevator starts to accelerate down. So if it's going to accelerate down, that means that the unbalanced force has to be down as well, which means that FG has to be winning the tug of war. Okay, so the cat is sitting in the elevator, which means it's touching the floor, so there will be a normal force, but the force of gravity has to be bigger if it's accelerating downwards, and we'll prove that a little bit later with the math. Okay, but in terms of our arrows, we want to make sure that those arrows are different sizes. Okay, so thinking about givens for step 2, okay, we know that the elevator is accelerating down at a rate of 1.5 meters per second squared. So that's my first given. So 1.5 meters per second squared down. And make sure you write that direction. That's equal to my acceleration. And the second given that I'm given is that the cat has a mass of 6.8 kilograms. So that mass is told right there. Mass is 6.8 kilograms, so we're going to write that down. 6.8 kg is equal to m. As always, we know that our acceleration due to gravity is 9.81 meters per second squared. That's equal to little g. We might need that. We probably will need that. We will need that for sure. Okay, moving on to step 3. What is our unknown? This example is a little bit different than ones we've seen. It's asking, what is the force that the floor is pushing up on the cat? That's our support force. That's our normal force. So it's asking us to find the normal force. In order to find the normal force, though, we are going to also have to find the unbalanced force. We're kind of noticing a trend here in all of these problems that no matter what we're looking for, we always do want to find that unbalanced force first. I said earlier that if we're going to accelerate down, that means that FG has to be winning the tug of war. So FG has to be greater than FN. If we're going to accelerate down, our unbalanced force has to be down. So FG is going to be bigger. So that relationship is going to help us when we are looking at step 4, our equations. What equations are we going to have to use? Well, the unbalanced force is just those difference in those opposing forces, so Fg minus Fn this time. And we're also going to use our Newton's second law equation, Fu is equal to ma. In this problem, we're actually given the acceleration. They told us what the acceleration is. So rather than using that first equation and then plugging it into Fu equals ma, we're going to plug in our acceleration to find our unbalanced force that way, and then use that top equation to find what the normal force is. So a little bit of a different process. We're kind of working backwards from what we have been doing now. Step 5, if you take a look at this top equation here in step 4, I'm going to have to rearrange it to find what my normal force is. And that's just some simple algebra subtracting over to other sides. So Fu is equal to Fg minus Fn. If I want to get Fn by itself and I want it to be positive, as usual, then I'm going to add Fn to both sides because I want it to be positive. I want to get rid of that negative. So it cancels out on the right side, and I am left with Fu plus Fn is equal to Fg And then if I want to have Fn by itself, I want to subtract Fu from both sides. So then my final actual equation that I'll be using, the rearranged equation, is Fn is equal to Fg minus Fu. So that is my rearranged equation that I'll be wanting to use to solve for Fn. So step 6, just checking our units for this rearranged equation. We know that the normal force is measured in newtons. We know that our force of gravity is measured in newtons. And that we know that since the unbalanced force is a force, it's going to be measured in newtons. And newtons minus newtons still gives us newtons, so we're good there. Finally, step 7, a couple things we need to find here. We're going to start with our Fu equals ma equation. So we're going to find what that unbalanced force is. So Fu is equal to the mass of the cat, 6.8 kilograms. And we're going to multiply it by the acceleration that we're given in the problem, which is 1.5 meters per second squared. And if we plug that into our calculator, we find that the unbalanced force is equal to, let's see here, 10.2 newtons, and that unbalanced force is in the direction of our acceleration, which is down. So Fu is equal to 10.2 newtons down. So now if I want to use my rearranged equation, Fn is equal to Fg minus Fu, I got to know what Fg is. So in each one of these problems that we've solved today, we had to find what Fg is. So when we're working in the y direction, up and down, it's always important for us to find Fg. So again, we're going to take the mass, 6.8 kilograms, multiply it by the acceleration due to gravity, which is 9.81 meters per second squared, and we find that our Fg, the force of gravity on this cat, the weight of this cat is 66.7 newtons, and again, that force of gravity always points down. So now finally we can actually find what we're looking for, which is my normal force. So I'm going to use that equation that I rearranged. My normal force is going to be equal to the force of gravity, which is 66.7 newtons. And I'm going to subtract my unbalanced force, which was 10.2 newtons. And my normal force, my normal force acting on the cat is going to be 56.5 newtons. And as always, our normal force points perpendicularly away from the surface, which in this case is just up. So that's my normal force. I have found what I am looking for in the problem. Again, this last example was a little bit different, where we were given the acceleration, so then we had to find the unbalanced force to then find our normal force. But again, in all of these problems, we had to find what our Fg is, because without Fg, we can't figure out any other forces acting in the y direction, up or down. So that is all for the examples for today, and you'll be solving some problems that look a lot like these ones.